Let's now comment on the continuity of these following functions. Now, by comment, what that really means is define where it is and is not continuous. Now, 3x plus 1, this is a polynomial. And polynomials are continuous everywhere. So this is continuous on the interval negative infinity to infinity. There are no values of x, none. You can't find any that would make this function undefined or discontinuous in any way. G of x equals cosine of x. Well, cosine of x, well, let me say this first. Both sine of x and cosine of x are in fact continuous everywhere. If you look at graphs of these, you can see it graphically. Sine looks like this, goes on forever, and obviously comes back the other way. And cosine looks like the same thing, it's just shifted over. Cosine looks like this and continues on forever. So sine and cosine are both continuous everywhere. So cosine is continuous everywhere. Now, that does not apply to the other trig functions. Matter of fact, the other 4 trig functions are not continuous everywhere. They have points of discontinuity. This next one, h of x equals 1 over x plus 2. Okay, now I'm dealing with something that looks like a rational function. Now I really need to be concerned about when the denominator is 0. Because when the denominator is 0, that's what's going to create a situation where I may have a point of, or will have a point of discontinuity. So, well, all I'm going to do is I'm going to take the denominator, I'm going to set it equal to 0. X plus 2 equals 0. That implies x equals negative 2. Now, notice that this is reduced all that it can be. I can't reduce this anymore. So, x plus 2 can't be canceled out. If it could be canceled out, then that's going to tell me I have a hole. It's not canceled out, so that actually tells me that I have a vertical asymptote at x equals negative 2. Definitely, without a doubt, a point of discontinuity. Matter of fact, this is an infinite discontinuity. Infinite discontinuity simply tells me that the function, if I were to graph it, here at negative 2, this function is going to look like this. At 0, this is a half. And I have a vertical asymptote. So the discontinuity is infinite, unlike something that has have a hole in it. Okay, x squared plus 5x plus 6 over x plus 3. Now, right away, I'm going to think, well, if I set the denominator 0, x plus 3 equals 0, that implies, x is equal to negative 3. But the question is, will this factor? And the answer is, it does. This will factor to x plus 3 times x plus 2, x plus 3. See, it cancels out, and I get x plus 2. So this function is equivalent to this function everywhere except for x equals negative 3. Because when x equals negative 3, this function will be equal to negative 1. This function will be undefined. That means in terms of graphing it, I can graph this just like this function. xy, x plus 2, see 1, 2, 1, 2. It's going to look like this. But the problem is when x equals negative 3. So at negative 3, rather than it being smooth like this, I actually have a hole right here. So that's my point of discontinuity. So this function is in fact discontinuous at x equals negative 3. So this would be continuous on all real numbers not equal to negative 3. Or you could say negative infinity to negative 3. Negative 3 to infinity. Either way, you're describing the same thing.